4, correct? I think we actually finished as the bell was ringing.
Yeah.
Is that right? I don't know if we got to. We talked about C and like to write out the definition of continuity. I'm telling you right now, they're going to tell you use the definition of continuity. Like if they tell you that, you have to write out the limit of f of x as x goes to c equals f of c, something to that effect. The name of the function may change. This one's g, all right? But check to make sure they match up. They meet up at -3. Question on that one? All right, the next one you guys did was 5. Which parts of 5? Help me out. A and B. All right. It's kind of funny because there's an AP calculus discussion board that I used to like be a part of. And I just kind of stopped. But it's funny because all the AP Calc teachers after the AP test, like after you're allowed to start talking about it, they like type out, "Oh, did you hear about this problem? Or did you see this problem?" Once they're released to the public. The baby bird problem that's a big one. It was a popular one. All right. Was this challenging for you guys? Actually, part C was the really challenging part, so you guys haven't gotten to that yet. All right. Here's what I would say. You need to be able to look at this problem and identify one key idea. What is it? dB dt, and what is in the problem? Or what isn't in the problem? All right, let's back up. It's crazy what a variable substitution would do for you. dy dx equals 1/5 100 minus what should jump out at you? The capital B or the y? And what's the problem here? What are we used to seeing? We're used to seeing x's in it, right? dy dx equals 3x minus 2. I don't know, whatever the derivative was. We're used to seeing dy dx having x's, correct? If it didn't have x's, and if it only had y's, then it was like an implicit differentiation kind of problem, right? Remember that? All right, so we'll get to that in letter B. Let b of t be the solution to the differential equation above, which with initial condition b of 0 equals 20. All right, is the bird gaining weight faster when it weighs 40 grams or when it weighs 70 grams? Gaining weight faster, and what you might want to write down is the units on this. What would be good units for dB dt? What are the units of dB dt? Grams per day? You guys agree? Grams per day. So if I'm looking for is the bird gaining weight faster, makes sense to plug that into the grams per day function and find out how many grams per day it's gaining at 40. Or sorry, when the weight is 40 and when the weight is 70, right? What's the problem? Well, back up. What's capital B stand for? The weight. So B of t is the weight. Well, aren't we going to plug in 40 for B? You okay with that? 100 minus 40? 60. A fifth of 60 is 12, I believe. Yep. 12. We didn't have to put units, but what are they? Grams per day. At a weight of 40 grams. All right, 70 grams, 100 minus 70 is 30. A fifth of 30 is 6 grams per day. Here's what you should write down. All right, if you want to get the explain your reasoning point, the bird is gaining weight faster when it weighs 40 grams. Your work is your support. Okay, if you labeled it correctly. All right. This is your answer with justification. The bird is gaining weight faster when it weighs 40 grams. B. You have to take the second derivative, which is the first derivative of this function. All right. How'd you guys do on that? Part B, you guys are supposed to score that. Did you get negative 1/25 times parentheses 100 minus B, or maybe negative 4 plus 1/25 B if you distribute? How many of you got that right? Part B. Do I need to go over it? I mean, only 2 of you got it right. Do you understand how to do it? Well, this is why it's so tedious. You guys don't talk to me. All right. Let's do this one. Ready? dy dx. What derivative rule is appropriate for this? Do I need a product rule? No, it's a constant out front. Constant multiple. Isn't the 1/5 going to go along? This is the second derivative now. What's the derivative of this term? Positive or negative? Negative. dy dx I hear. Yes or no? So if you're not quite sure of this, like if you're not quite sure of what the notation would be here, you can treat it, you could think of x's and y's just to get your brain going, but you do need to use correct notation. All right. So we go over to this one now. D squared b over dt squared is 1/5. Goes along for the ride. The derivative of 100 goes away. Negative d b dt. So this is negative 1/5 db dt. Are you with me? Negative 1/5 db dt. What's the question? Use the second derivative to explain why the graph of b cannot resemble the following graph. Well, if the second derivative is negative 1/5 db dt. Let me read the directions again. Okay. Time, days, weight, grams. Describe what's happening to the weight of the bird. It is strictly what? Increasing. Good. The graph is strictly increasing. What is dB dt if the weight graph is always increasing? dB dt is always positive. Do you agree with that? Okay. The graph here is concave up or concave down? Concave up, then concave down. Point of inflection there. So back to the story. Use the second derivative to explain why the graph of b cannot resemble the following graph. Why is that not the correct? Why can't that be the correct b graph based off of this reasoning? dB dt is always positive. Well, if dB dt is always positive, what's negative 1/5 times positive? Negative. The second derivative should always be negative. Do you agree? What should the graph of w always be? if its second derivative is always negative? Concave down, right? So that's tough. Let's just agree. This is a tough problem, right? That's a tough problem. You have to kind of chip away at it, all right? Portion of the graph is concave up. It can't be that way, all right? You could put the second derivative is always negative. That can't be the graph because it's concave up in some portions. That would be fine too. All right, let's keep moving. What part of 6 did you do? A and C. All right, particle moves on the x-axis, velocity of the particles time t. Particles are position t, okay. When is the particle moving to the left? Did you set v of t equal to? You didn't have a calculator for this, by the way. Did you stick to that? Do it by hand. Okay. Did you find out when the velocity was negative for part A? Were you okay with setting that equal to 0 by hand? Did you get 3 and 9? Please be honest with me. Did you get 3 and 9? Cool. You guys good? I see a couple no's. All right. Cosine pi over 6t equals 0. Why am I setting it equal to 0? Because I want to find the intervals when it was moving to the left and then to the right. Well, when's it going to stop moving left and start moving right? When the velocity is 0, right? Change in direction. So I want to find out at what times the velocity is 0 and then test the intervals where that happens. All right? Only from 0 to 12. How do I solve this? I need to get t by itself. We'll get rid of a cosine. Cosine inverse. If I do it to the left, I have to do it to the right. Pi over 6t equals, what's the cosine inverse of 0? I hear pi over 2. Pi over 2? No, you're not. Not 1. What question is cosine inverse of 0 asking? At what radian measure is the cosine 0? Okay, ready? 0 radians? No. What's the cosine here? Well, the point is 1, 0. The cosine is the x. It's 1, not 0. Not at 0 radians. Ready? What's the cosine inverse of pi over 2? Sorry. Gave it away. If the cosine of pi over 2 is 0, then the cosine inverse of 0 is pi over 2. I need to write that out. I think this is one thing we've talked about this year. You guys gave me some weird looks, which is kind of normal. If the cosine of pi over 2 is 0, then the cosine inverse of 0 is pi over 2. And I think I asked you earlier in the year, have your teachers ever taught you why this works? We need to do this quickly. I'm sorry. You guys need to answer me. I know this is slow. I know this is tedious, but this is really important. I need you guys to get this. I would say, from my experience, our understanding of inverse functions was weak early in the year. I tried to help you. Let's see if it made any difference. Okay? What's 3 squared? 9. What's the square root of 9? 3. Inverses go forward and backward with the regular function. What's 5 times 4? What's 20 divided by 5? Inverse. What's the cosine of pi over 2? What's the cosine inverse of 0? Why? Well, If multiplying and division undo one another, if squaring and square rooting undo one another, then there must be an undoing function with cosine. It's called the cosine inverse. So if I undo it, what happens? Cosine inverse both sides. And this is what I told you guys earlier. I wish your teachers would show it this way. I think this process is abstract to you because it was never concrete to start with. Do you know what I'm saying? Like elementary school, you actually had 5 groups of 4 whatever, marbles, dice, whatever. 5 groups of 4, multiplication, right? If I add 7, how do I get back to where 7? Take away 7. This is the taking away thing that I don't know it's ever shown. Do you see how green and green have stayed? I cosine inverse both sides. If multiplication undoes division and squaring undoes square rooting, and vice versa, then shouldn't cosine inverse undo a cosine? And what am I left with? So the cosine inverse of 0 is pi over 2. How am I showing you this? We good? Cosine inverse of pi over 2. 0 is pi over 2. Okay, let's keep going. Ready? Wasn't 0 radians. Pi over 2, check. Am I doing it backwards for you guys? No, pi. Cosine of pi. If the cosine of pi is -1, then the cosine inverse of -1 is pi. That's not it. What's the cosine of 3 pi over 2? 0. So the cosine inverse of 0 is also 3 pi over 2. Are you with me? All right, where are we? We're here. The cosine inverse of 0. Thank you. How do I solve this? Multiply both sides by? Don't divide by pi over 6. Multiply by 6 over pi. You were taught that, right? Multiply by the reciprocal. Multiplicative inverse. All right, anyway. 6 over 2. T equals 3. Multiply by 6 over pi. 6 times 3 pi is 18 pi over 2. Over 2 pi, sorry. T equals 9. Units here. Did it tell us units? I don't think so. It didn't tell us what the position units were in the time. T equals 3, T equals 9. That is when the particle is at rest. Do you agree? All right. So we have a number line. We have 3. We have 9. We have endpoints that were given of 0 and 12. We're going to test before 3, between 3 and 9, and then between 9 and 12. Those are going to be our test points. What are we looking for? When V of t is negative, because then the particle will be moving left. Make sense? Go ahead, test a few points. Again, all I care is positive or negative. What should I plug in here? What should I plug in here between 0 and 3? 1. Into velocity, right? What's the cosine of pi over 6? I don't care. Just tell me positive, negative. 0. Yeah, because first quadrant, cosine's positive in the first quadrant. V of t is positive. That's moving to the right. I don't want that guy. Pick a number between 3 and 9. 5? What's the cosine of 5 pi over 6? 5 pi over 6. Which quadrant? Second quadrant, right? Remember me teaching you guys numerator is 1 less than the denominator? Second? 1 more than the denominator? Third? 1 less than double? Fourth? Second quadrant. Is the cosine positive or negative? Negative. How about 11? 11 is between 9 and 12. What's cosine of 11 pi over 6? Wait, 11 is 1 less than double the denominator. That's enough. Fourth? Cosine positive or negative in the fourth? Positive. The particle is moving to the left between 3 and 9, whatever units. That's how you should approach that kind of problem without a calculator. Does that make any sense? Inverse operation. Inverse operation. All right. Part C. Find the acceleration of the particle at time t. Is the speed of the particle increasing, decreasing, or neither? Okay, so there's a physics application. How many of you have never taken physics again? Help me out. Never physics. 1, 2, 3, 4. All right. I'll try to explain it 2 ways then. Find the acceleration. Acceleration was the derivative of cosine. Chain rule, by the way. Derivative of cosine. Negative sign, leave the inside alone. Times through the inside. Negative A of t is negative, where am I? Pi over 6 times the sine of pi over 6 times t. Double check me, is that right? Yes. That's A of t, got it. And train yourself to start thinking, okay, they asked me for acceleration. Find the acceleration. Probably a point for that because they asked me to do it, all right? Then, is the speed of the particle increasing, decreasing, or neither? And then explain. I'm guessing this is either 2 or 3 points. 3 points. Okay. So, I found the acceleration. 1 point. Perfect. Next. How will I tell if okay, we'll start with the physics people. How do I tell if the speed of an object is increasing, decreasing, or neither? How do I tell? If the velocity and, is that what you're saying? Sorry, go ahead. The sign of acceleration? I thought there's a second component that has to do with velocity and acceleration. Didn't you guys learn that? Well, we were given the V of t graph. Dom, I'm not saying you're wrong. I'm just not smart enough to know if you're right. Let's just work with this V of t graph, okay? All right. Oh, did you say if A of t is positive?
If A of t is positive, then it's increasing.
What's increasing?
Speed. Velocity.
Velocity is increasing. I agree with you. Because acceleration is slope of velocity, right? And if A of t, if the slope on the velocity graph is positive, then A of t is positive, right? A of t is positive, 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 negative, A of t is positive. Do you agree with that? Everybody agree? Okay, so maybe maybe acceleration would look something like this. Do you agree that could be the acceleration graph? Okay. But when is the speed increasing? Cool.
When the acceleration is positive at the first part, and then when the speed is going past the x-axis at the bottom.
Are you saying here?
Yeah.
Is speed increasing there? Is speed increasing here? Do you agree? Physics people, do you agree? Okay. We're going to break it down into two different categories. If you've taken physics and you understand this, you would say speed is increasing when A of t and V of t have the same sign. That would be a physics argument. Do you agree with that? Cole just said velocity is positive here. You're looking at the green velocity graph. Isn't that graph above the t-axis? It's positive. Acceleration is the slope of velocity. The acceleration is positive right there. Can you see it? The slopes are positive. Velocity and acceleration are both positive from here, from A to B, and then from C to D. Are you with me? That is when the speed is increasing. What else did they ask us? Is it increasing, decreasing, or neither? Okay. There is your physics argument. If you want to write that on the AP test, you are perfectly fine with that. Okay? I want to, for those of you non-physics people, did that make any sense? Or do you need me to explain it another way? Non-physics people again? Who was non-physics people? Did that make any sense to you? It's okay if you say no. Okay. What's happening here? Let's ignore acceleration for a second. This is challenging for me. I have to explain it in a non-physics way. All right. What's happening to velocity here? It's positive and increasing. I'm going to walk this. Are you ready? I'm moving to the right, and I am speeding up. Okay? Ready? Velocity is positive and increasing. Then my velocity is positive and getting closer to 0. Positive, they're getting closer to 0. Oh, I'm slowing down. Okay? Then my velocity is negative and getting more negative. Negative and getting more negative. Negative 2 feet per second, negative 3 feet per second, negative 4 feet per second, negative 10 feet per second. That was a close one. Good, my velocity came closer to 0. So let's just make a rule. Yeah, if velocity and acceleration have the same sign, the speed is increasing. What about, let's make a rule. If the graph is moving away from the t-axis, it's either positive and going up or negative and going down. The object speed is increasing. Would you agree with that? If it's positive and going up or negative and going down. Right? That's the same thing as saying velocity and acceleration have the same sign. Positive and going up means velocity is positive and it has a positive slope. Negative and going down means it's a negative value and a negative slope. Same thing. All right? What if they have opposite signs? The object its speed is decreasing, right? And then if the speed is neither increasing nor decreasing, it is, careful, constant. It's a constant speed. Would you agree? I've done it, but I haven't got 100%. Okay. We found the acceleration, and we're plugging in 4. Let's plug it into velocity. What's v of 4? V of 4 is the cosine of 4 pi over 6, which is 2 pi over 3. What's the cosine of 2 pi over 3? I don't care. It's cosine of 2 pi over 3. Negative. Negative velocity. Negative velocity. Acceleration. What's a of 4? Well, what's the sine of 2 pi over 3? The sine is positive times a negative pi over 6 is negative. Is that Tyler? It's live. Velocity is negative. Acceleration is negative. So for letter C, the speed is increasing. Now they said because velocity and acceleration have the same sign. If you're not a physics person, that is one of the very few things from physics you actually need to just kind of commit to memory. If velocity and acceleration have the same sign, the speed is increasing. I tried to present it in a logical way. Hopefully that made sense. Yes? Was that the last part? I'm going to take a nap. All right, take out your notes, please. I should probably say something like, thus concludes the 2012 practice test review. I feel like there should be some kind of conclusion. No? Wow. Thanks, Cole, with the C. Your coolness just got elevated. Notes out. Notes out. Lizzie. Remind me at the end of class and I'll take a look at it. Thank you. New chapter in our lives. Estimating with finite sums. Estimating finite sums. And you're only going to have a very simple homework to do tonight. Simple homework. And it has to do with your velocity graph, okay? You're going to graph your time velocity data on graph paper, okay? If you don't have graph paper, Google it. You can print out blank graph paper on the printer, okay? You're going to graph it, and something I'm going to warn you about, the first interval was 10 seconds. Then, I know I'm just kind of spreading these out so it doesn't look so jumbled. 10 seconds, 20 seconds. You can let every box be 10-second intervals if you want, and on the grid of the graph paper, that's fine. Just make sure you probably want to go landscape, okay, so you have enough room to go horizontally. And then if your y-axis, your velocities are incremental, like if you, there shouldn't be any 80s or 70s on there, okay? But decide what would make sense for your data. If yours goes up to 50, decide what units. If you want to go every 2 units is 5 miles per hour, whatever you decide is fine. That doesn't matter as much, okay? Just decide what the correct scale should be for your velocity. Here's what you're going to do. You're going to graph your data as a scatter plot. Okay? Do not connect them. Do not connect them. We don't need to do that right now. Okay? So you're going to graph your data on graph paper with accurate units. Whatever scale you use for the vertical, the velocity, please mark it on there. And then we'll see how far we get in the next couple days. This will kind of be a part of our homework over a couple different nights just to kind of walk through this as we learn the beginnings of chapter 5. 5-1. You're gonna watch a recorded video from last year tomorrow. I apologize. I will be here in the building, but in a meeting all day. I'd rather be teaching calculus. Just see these wonderful smiling faces, engaged and ready for knowledge. Okay. All right. Let's break our driving activity into the most boring driving activity of all time. We started recording at 1 hour. We stopped recording at 3 hours. I hope none of you drove for 2 hours, but you get the idea. T is measured in hours. Okay? Now, another thing I should say about this. You can graph in seconds, but later on, when we go to calculate hours, you're gonna have to convert 10 seconds to hours. Okay, you have to convert these to hours. So don't do any calculations yet, but we're gonna convert these so we can have miles per hour and hours, and then have accurate units. Okay, so this graph, this example we're doing up here is already converted to hours, and our V of t graph is here, and we drove 50 miles per hour for 2 hours. Pretty exciting, huh? Just cruise control. What is the area of that section? 100. What would the units be on that? Well, the base is measured in hours. The height is measured in miles per hour times hours. Ends up giving us a unit of miles, 100 miles. Now, that's kind of over explaining it. We all know if you drive for 2 hours at 50 miles per hour, you've driven 100 miles. It's easy. What if this was our velocity graph? Ooh, it's supposed to be continuous. That'd be an exciting velocity graph. Where'd you go? How'd you calculate that, Cole?
Solve it as a trapezoid.
Huh?
Solve it as a trapezoid.
Okay.
You'd use the height of 1 and the height of 3, and you divide it by 2 and multiply it by the interval.
Fancy. Trapezoid is 1/2 b1 plus b2 times h, where h is the distance between the parallel bases. Remember that? So my parallel bases are actually vertical. So we would need 20, 50, and then what's h? 2. And so 1/2 20 plus 50 times 2. Well, 2.5 cancel. What do I get? 70 miles. It's getting more exciting now, isn't it? I mean, if you're a grandpa, it's about how you drive. Don't take that as a challenge. But that's a pretty big but. What if our data is more like that? Jackson's getting excited. It's like a pretty big but. Jackson. I love Jackson, right? Who doesn't love Jackson? Likable guy. What do you guys think? I'm going to find the area of that thing. Cole?
You can use either Riemann sum or find the integral.
Oh, you nerd.
Yeah.
What's a Riemann sum?
It's the approximate sum underneath a curve, solving by either the left Riemann sum, where the point at 1 has the interval, to the left, to the right of that point, or the left Riemann sum, where it's the left,
You knew as soon as the parents named him with a K. These are the kind of answers he's gonna give an AP Cal. You know that? Choose wisely when you name your children. Cole the C would not have said that.
His mind's blown over there.
All right. So here's what I will say. Part of the recorded lesson is going to be kind of boring because we walked through some of that. All right. So pretend you didn't hear it. And there's no Cole with a K insight into what's going to happen. But here's the information that was challenging for, I don't even want to say early mathematicians, early to calculus mathematicians. All right. How do we find the area under that thing? Just hang with me here for a minute. Area under a rectangle, it means how far did you drive? If it's a velocity time graph. Are you with me? Area under a trapezoid, same thing. Isn't the area under this curve going to mean the same thing? What are the units going to be? Miles. And it's going to be how far we drove, right? But how do you calculate that? And so Cole kind of alluded to it. What if we broke it up into shapes we know? Is one rectangle going to be enough? That's not going to be a very good estimate. How about that many rectangles? Continue. Maybe, but that area, I don't know, it's not great. How do we do this, right? That's the question that's going to kind of guide the beginning of this chapter. So chapter 5 is going to have to do with areas and then how to calculate areas under a curve. To be continued.